garbage. I can Swiss even. Hey everybody, yeah, today's going to be our last class of this. It's been super fun to have all of you guys. Thanks for putting up with my highly variable levels of teaching ability and instruction material. Yeah, today's going to be kind of just a loose, I'm going to go through a bunch of slides that are going to be like, where to go here? You know, I hope we're giving you guys at least a basic framework for concepts around data and functions and a little bit of objects. But yeah, like probably the next best step for most of you guys would be to find a project that you want to work on. And so today's lesson is kind of just about like what tools are out there, what languages might you want to use, what frameworks. Should you like start poking around looking for tutorials and maybe starting to start working on a small project or two that'll be the most useful for your stuff. So it's like Python is great for some things, but in terms of a creative coding environment, it's not super useful. Or most creative coding problems, like there are better tools to use. So yeah, I'm gonna go ahead and hit the old screen share button. And make this a little bit bigger. But yeah, so where to go next from here is going to largely depend on what you want to do. So step one, if you want to make pretty 2D things, especially things that involve like animation, things that move around, processing is probably going to be what I would recommend you use, mostly because of this, the fact that it just has a ton of libraries, and I would venture to say it's probably the most popular creative coding platform out there for like actual like typed out code, and certainly the most popular for beginners, which is super awesome because it means that a lot of the code examples and a lot of tutorials out there are going to be written for the perspective of people who don't have a ton of computer science background. There are a couple of caveats. So one thing, not a caveat, but processing is basically the Java programming language with...
so that's the name of the language. Processing is the language.
So Java is the language. Okay. Processing is the... So these are, a lot of these things are known as programming environments. And or we'll get into frameworks a little bit later. The difference is, it doesn't really matter that much. You can call processing a framework, actually, probably. So processing is, so processing.org. There's a little like, let's see if there's an image of the processing editor. But yeah, there's a ton of, so it's been around for over a decade now. Started by some dudes there at MIT's Media Lab. It's been just used by a bunch of things. There are a couple of cool things that you can eventually cool, more advanced stuff you can do with it. One of the nice things is that they're working a lot to stick it on the web. So you'll be able to actually write processing code on an HTML document or like on a website and actually have your content run to the web. So
that would be cool. So you wouldn't need like you just run it on the web. That's cool.
I'll pull up an image. So processing looks like this. It's a tiny crap image.
It's free. You can download it.
Yeah, it's processing totally free. Let's zoom in.
Now, can the iCloud that we were using?
Oh, Cloud9.
Cloud9. Does it have processing and a simulator or
it
runner?
It does not.
Okay.
So Cloud9 supports a couple of other languages. Cloud9 is awesome just because it's collaborative. So if you're working with other people distantly, that's why you would want to use Cloud9. I think it's primarily designed for like web developers probably. So if you want to use JavaScript or server-side stuff, it might be a cool tool in your toolbox. But this is what the processing environment looks like. So you've got this little window where you can write code, and then you hit the play button up here, and it spits out like an output window that shows the results of your program.
It's pretty cool.
So yeah, and especially now with Processing 3, the Processing 3 editor has some like nice functions like autocomplete code auto-completion, and it'll like be automatically like you'll type something in, and then after like a half a second or something, if there's an error, it'll like say, hey, you've got an error in this line. So instead of like hitting play and then being like, it'll get you an error and kind of tell you where it is. Processing used to be way worse. The error messages particularly used to be just garbage, but it's got way, way better in the last 5 to 10 years. So I used to hate it, but now I strongly recommend it. So this is like
2D stuff.
For 2D stuff. You can get into 3D stuff with it, but I would not recommend it. It gets real mathy real fast, like in a real serious way. The big things you want to watch out for processing. So Processing 2 was kind of the main version of it for the bulk majority of its life. Processing 3 has only been released in the last year, and they're not completely compatible. So there are like a lot of libraries for Processing 2 because it was super popular that aren't necessarily don't necessarily work with Processing 3. So if you go to process, you can notice that like if you're not getting compatibility, you go to the download page, it'll give you the latest version here. Ooh, they came out a new version. But you also have the older releases, so like you can get 2.21. Occasionally you run into a really old version that'll need like version of code that'll need like Processing 1.5, which again, so a lot of times in programming, like the first number on the version number is like the main version number, and when that changes, there will be potentially like incompatibilities with previous code. Like a big number version, like is kind of can be a statement of, hey, things you made with previous versions may not work. Yeah, so there are incompatibilities between the two. They changed a lot of stuff, made a lot of stuff way better, but especially some libraries may not work. So like my desktop has a folder with Processing 2 on it and a folder with Processing 3 on it. The other thing, especially with the switch to Processing 3, audio and video have always been handled by external libraries. Video used to be like a library that they distributed with processing. They split that off because it's gotten really big. And with Processing 3, video is still kind of a mess. It works with OS X, doesn't necessarily work with Windows yet. So if you want to do a lot of stuff with working on video, there are probably better options that I'll talk about later. Audio, yeah, it's basically some dude's kind of side project that like he came out with a library to do audio stuff, and it works. You can get it to spit out video, or audio, I mean, but it's definitely not. I wouldn't use it if I was gonna like try to do creation with audio or something that involved like audio as a main piece. I would probably do that separately. I should have had a slide. I might write a slide in towards the end just about how to. One thing I've found it's super useful in the last couple of years is like protocols that let one program talk to a different program, and that can be super handy. So maybe you have like an audio program, like an audio piece that's written in like Max that interacts with a processing program. And you can send messages between the two to like sync them up or have them do different things, or have processing handle like the interaction part and just feed that information into Max.
You can pull all of your numbers and stuff from processing, and they get distributed to Max and do all the stuff.
Yeah. Especially if you want to do stuff like Connect or things that like, it's a good way, like processing like has a lot of libraries, so a lot of tools that hello. A lot of tools you may have used, like that somebody's written like an easy-to-use toolkit for processing, but you want to use Max or Unity or something. You might be able to just have a processing program that only handles like data from the Connect, and then you send that data out to your other program that you're actually writing things in. So if you want to go above and beyond processing, Open Frameworks is quite popular for like the more hardcore nerds in the creative coding world. It's lower level. It uses C++ instead of Java. The big change between Java and C++ is C++ asks you to keep track of actually like the memory that you're using. So whereas Java is like, hey, you created an integer or you created an image, like I'm just gonna ask the computer for a certain amount of RAM and use that. Whereas C++ is like, hey, when you create something, the programmer usually will have to tell the operating system, hey, I need enough RAM for my object, and then when I'm done with the object, I need to give that RAM back. The plus side is that makes open, since for a couple of different reasons, Java is about 5 to 10 times slower than C++. Java is still pretty fast for most things, but yeah, if you need to crunch through a lot of data, want to do really complex stuff, you want to do really intensive graphical things, and processing's choking on things. Talking to somebody and getting started with open frameworks might be an option. But C++ is probably, like in my coding career, I went through basically the first entire year of programming before the third year or the second year they were like, okay, now we'll start talking to C++ because it's helpful to understand. C++ is it's like a butterfly knife. It's you can do a lot of cool tricks with it, but it can also cut your fingers off real easy. So, yeah. So, 3D things. So this is more on the level of you want to create full-blown scenes and environments with multiple 3D objects that come from somewhere else and interact with things, or you're kind of generating objects and moving a bunch of different objects. My first recommendation would be, sorry, does anybody have any questions about this 2D stuff?
So that when you say 2D stuff, you're kind of saying that those are really good for static.
Not static stuff. They're really good for moving.
So that moving though usually is different than
Yeah. So when I say video, processing doesn't do a very good job. You probably need probably want to use an external program to capture the visuals that you're creating with processing, because processing doesn't have built-in oh, take this and make a video out of it. Processing's a real time. Okay, make a bunch of shapes, do a bunch of things in real time, and interact with the world.
Yeah, maybe maybe you could probably find something online that was made with processing.
Yeah.
That's
Let me screen share real quick.
Video is just a series of sequential images that get played.
Yeah.
Whereas processing the images are being generated real time.
Yeah.
Yeah.
So let me go. So I'll talk about this in a little bit later. Processing.js, and now actually kind of switched over to P5.js would be even better. This is kind of the processing for the web. Let's see if there's gallery. Here we go. So this is just give me a link to your stupid blog. Give me the actual goddamn.
Yeah, I just see this.
There you go, assholes. Let's probably be Tom. Looks like it's in 3D. Do whatever. I'm just stupid Lady McLadersons. But yes, these are kind of little GIFs that person made. This looks nice and abstract. Chug. So this is the type of thing that you do in processing. So it's dynamically generating this content.
This image.
It's pretty. So this is like some points that like are attracted to my mouse. So like I've done a ton of work with processing, making cool, fancy things happen. But yeah, so this is all real time, all generative art versus like video where you've taken a bunch of pre-created elements and are just showing the video and manipulating a video. Like so you have all this like pre-recorded video and you want to like mess around with that. Processing's not great for that.
This is Java.
So yeah, this is
Sounds pretty nice.
yeah.
A lot of them are dreamy, kind of dreamy.
Yeah.
I like what you did for the whatever that show was.
Uncharted?
Yeah.
Yeah, super cool.
Yeah. I was like kind of actually paying attention more to that than I was.
Yeah, there's a few points I was just checking that out.
Yeah, so moving on to 3D things. This is like, again, creating scenes. So if you want to, we'll talk about 3D modeling in a little bit and using code with that. But yeah, if you want to make like 3D scenes, you can technically do that in processing or open frameworks or in a bunch of languages. It's super gross. I would start with the Unity game engine. So this uses a language primarily uses a language called C#, which is like kind of halfway between. It looks a lot like C++, which actually looks a lot like Java anyways. You don't have to do memory management. It comes out of Microsoft, so you can use Visual Studio and Visual Studio to edit your code if you're on Windows PCs, and Visual Studio is awesome. And it's free, the community edition at least. So you can also program it in JavaScript or this other kind of minor language called Boo. Most people do C# with Unity. But let me pull up it. So Unity has got a drag and drop interface for the most part. And again, it's free, which is FL. Yeah, so this is the Unity editor, and so you can pull in objects. Like this has just a terrain object in it, but you can then create, bring in 3D models and then assign code to them. So the way Unity works is that you stick in your assets, and then you take code bits called components, and you attach them. So you might have a component, like they have built-in components like colliders, which allow things to like have physics, or you can write your own things that create particles or generate things or move things in specific ways. But it's got a little like play button here that makes it run as long and you can view all the data that's going on in it. So Unity started out probably about 5 or 8 years ago as this 3D game engine. It was competing with all the like 3D game engines at the time were like starting at like $20,000 to use, and so they're like, we're going to make a free one and just make a pro edition that people will pay for. And now their licensing is a little bit different, but it's still largely free to use. It's just if you start making a bunch of money, they start taking a chunk of it.
What? Are you haven't talked about Unreal yet?
I have not.
Okay, good. I'll ask that then.
It's super popular because it's been free the longest. It's got an awesome community, tons of resources, tons of libraries, tons of examples of people starting out doing things, and people being like, oh, I have this like really like this question, and people giving answers to that. So it's pretty well designed for kind of more beginners. Its main competition when it first started out was the Unreal Engine, which is a video game backend that's used by a ton of like super popular mainstream game, like AAA quality games. It's programmed primarily in C++, so gross. But it also has this patch-based, and we'll talk about patch-based a little bit later. This patch-based like blueprint system on top of that, which kind of lets you take in code and just kind of like easily link it together graphically. It's probably more powerful than Unity, but you have to work harder to like do things probably. Somewhat less free-ish. I've never really used it, so.
What do you mean by that? Less free-ish?
Their licensing has traditionally been more draconian. Like, so if you make money off of it, like their Unity's licensing terms used to be like it's totally free, and then but the paid edition has better features. They've added those better features for the most part, but now Unity I think is like if you make over $100,000, then you have to start paying them. Whereas I think Unreal is like if you start making any money, maybe, or maybe it's over like $2,000, like you have to give them like 20%.
Oh.
So if you were to use Unreal
So for art stuff, this isn't a problem at all.
unless you sell your art.
I'm making.
But if you did a commission, for $10,000 using it,
You'd have to charge 20. You'd have to charge.
Yeah, it's $2,000 that you'd have to throw to make us Unreal.
$1,200 for
So,
your commission.
Oh, throw me in the briar patch.
Finally, you could be super hardcore and learn OpenGL and learn graphics programming. You will earn my undying respect and admiration.
I hope you like that.
It gets real gross. I mean, like, real gross.
Oh,
Specifically, I'm going to actually add this in. If you are interested, linear algebra is what you need to start.
I feel like I need to take some math classes. I didn't pass algebra. I took the class and got a grade, but I didn't.
Algebra or linear algebra?
All of it.
Sure. Yeah, actually, honestly, for a lot of this stuff, a lot of programming involves like mathematical problem solving. So maybe looking for a MIT OpenCourseWare sort of thing for algebra or
Khan Academy.
Yeah, Khan Academy would be good.
You could do
brush up
tutorials
if you haven't done
Yeah.
math in a
That'd be a great
decade.
way to go.
Yeah. I wish I could go on sabbatical and be a calm.
So, yeah, any questions with those guys?
Why did you write? Can we go back to that? Sorry. Where is the page? Sorry. Where did you write OpenGL and oh my god, I've lost it. Oh, OpenGL, Open Frameworks, Cinder, and Processing. I'm kind of confused.
Sure. So those are all examples of. So OpenGL, Open Frameworks, Cinder, and Processing. You'll actually be writing code for OpenGL. So OpenGL is this like basically language that specifically talks to your graphics card. And so you would in Open Frameworks or Cinder or Processing. Cinder, I was going to mention it last time, but I forgot. Cinder is a kind of an alternative to Open Frameworks that's a little bit more self-contained, whereas Open Frameworks is a little bit more use a bunch of libraries, import a bunch of libraries from everybody else. Yeah, so you'd be using one of these three environments to write OpenGL code.
I once took a class on Max MSP. Actually, it was Max Jitter. And they were talking about OpenGL also.
Yeah.
So is that possible?
So OpenGL is basically like an instruction set. It's what's known as an API. So it's a bunch of functions that you can call that your graphics card knows about. So it's basically one of the main ways to tell your graphics card, hey, do something. And that something might be draw a bunch of triangles, which is how to make like 3D objects in on your computer. So
So, but this is different in terms of pretty 3D things. We're talking about pretty virtual 3D things. We're not talking about interfacing with 3D.
That's correct. We'll get to that. So, if you're interested in VR, are any of you guys particularly interested in VR?
Yeah, probably.
Yeah, but I'm not quite convinced by it yet.
What's VR?
Virtual reality.
Oh, okay. So.
Yeah, use Unity. It's easy to use. It's my understanding is it's what everybody basically was using from the start when like Oculus kind of came out. So I don't know. Excuse me. I don't know a ton about like the environment, which is kind of embarrassing since I've had residents doing it for like 3 months now. But it seems like everybody's been using Unity on it. It's got good support for all of the platforms: Oculus, Vive, Cardboard, and Gear VR. So you're going to have probably the most support for it. Unreal Engine is also an option if for some reason you don't want to use Unity. Maybe it's if you like the patch-based programming, like one of our guys is using it because he's like a sound guy, so he's used Max MSP a ton, and so he's just using the patch-based interface on Unreal. So that visual style of program is more comfortable for you. It might be a decent option. CryEngine is another engine that you could use. They just decided to come out as a free game engine. They've been kind of known for being like the most graphically beautiful, pixel-pushing, polygon-generating one. So if you want to like be kind of cutting edge or different and just try something that's going to have way less support, you poke around with that. But otherwise, Unity is kind of going to be your gold standard there, is my understanding. Yeah, moving away from stuff on a computer. So that interacts with the real world. Got a couple of slides on this. Low-level edition. So it's just kind of stuff that's more like directly interfacing with hardware. Arduino. I imagine a lot of you guys know about that. Programmed in C/C++, but the things an Arduino does are like really basic most of the time. So like a lot of the trouble that you'd wind up getting into with C++ on a computer, you're not going to run into here. Like Arduino doesn't have an operating system to screw things up with. Arduino, basically, you give it C++ code, and that's the only thing it's doing. So it's a lot easier. There's a lot less danger in it, I guess. It's harder to screw up. You have really tight control, which is relative to the going to be in relation to like the Raspberry Pi of the timing on for the I/O pins. That's basically Arduino has like 21 like actual like physical electrical outputs that you can like plug things into. So you can like plug in a sensor or have it turn on an LED or have a motor run from it. So if you want to have something that turns things on and off, that interfaces with like a basic sensor, like a photo sensor, a rangefinder, basically if you want to have something like react to like pretty basic input, like buttons, if you want people to like press a button and it does something, Arduino is a beautiful way to make that happen. It's been out for, again, it came out of the MIT Media Lab. There's tons of libraries out for it and guides for beginners. It's like...
Yeah, you can go down to your local whatever.
Yeah,
store.
Radio Shack sells them.
Radio Shack.
Yeah, there were a couple of other. So Arduino uses what's known as a microcontroller, which is like, it's a chip that's like a really basic computer. There were a couple of competing brands, and just Arduino just came and just beat the crap out of them. So yeah, the kind of trade-offs are it's not very powerful as a chip. It runs at like 16 megahertz, whereas your computer at home runs at like 2.6 gigahertz. I mean, this is like way less powerful than like the 486 you had like growing up.
But it's really good at doing simple things.
But yeah, if you want to do simple things, they're cheap, and again, the tons of libraries things like if there's a project that interfaces with the physical world, like it's probably you can find somebody who's like done at least part of that project for you already, and just steal their code. Instructables is covered in Arduino projects. Yeah, there's a bunch of stuff on GitHub, tons and tons of code out there, tons of guides. And yeah, the sensors, there are a ton of people who are designing like sensors and like other electronics modules that like just plug right into an Arduino board. So it's really the way to go. Raspberry Pi so our Arduino is about $20. Raspberry Pi, the board itself is like $35. Then you have to buy an SD card for it. So end of the day, it's going to be about $45 US. Sorry, Lauren.
Just stop
me. Or if you want to borrow one, just ask me. Because I have a lot of them now.
It's substantially more powerful than an Arduino, and so right now we're on we're on the Raspberry Pi version 3 on each, like whereas the Arduino is the same chip forever. The Raspberry Pi keeps getting more powerful, and now with the Raspberry Pi 3, I would really start recommending it. It can do some cool stuff. The Raspberry Pi 3 comes with built-in Wi-Fi, so it is a good way to so it's a good way to do things. It runs an operating system, Linux, which now actually it defaults to having a desktop, so you can plug a mouse and a keyboard into it, and you can like easily connect it to the internet. You can open up things in a browser. You can actually run processing on it. So for $45, you can have something you can like actually have this thing that you can stick in a gallery or somewhere and run processing on it and have that pumping out over HDMI connection to a projector or to a screen.
They're cool.
Yeah, and they're cheap, so you can buy multiple of them and connect them together via Wi-Fi and stuff and do crazy things. Other languages are available. It's got Python, it's got Java. You can write C++ for it. You do have to use Linux on it, which I hate. It's just not that user-friendly. Like I was trying to set up some code somebody had written for Linux and for like a slightly different flavor, and I like spent like an entire day on it, and it still didn't work. So, and Linux has a very like do-it-yourself, like there's a lot of like presupposition that like you've been coding for 2 decades and know the ins and outs of Linux. There's a lot of like command line stuff that you have to do to change options, as opposed to like actually making it easy to use. But that's the trade-off. It's also, I mean, it's $45, so that's nice. Kind of sidebar, getting data in and out. So input, sensors, you have tons of cool options. A lot of them most of them will communicate either over like a standard digital protocol, like what's known as like the serial UART protocol, or I2C, or a ton of like standard protocols that your Arduino or Raspberry Pi probably knows. Arduino has more options for doing that. Or that's like an analog sensor that just like gives just a voltage value that you just read from the thing. One of the things I forgot to mention, so if you really want to interact with like physical stuff, so the Raspberry Pi has like I/O pin, input-output pins that you can plug stuff into. They're not as good as the input-output pins on an Arduino because there's like a level of software through it. I don't know if it's got any analog stuff on it, so yeah, there's tons of stuff that plugs into an Arduino. Not as much stuff necessarily plugs into a Raspberry Pi, but yeah. Basic like on-off stuff like buttons will do a Raspberry Pi well, though. Yeah, so input.
Did you hook up Arduino to a Raspberry Pi?
Yeah, you can hook up an Arduino to a Raspberry Pi, and so something that's actually.
So you could use the sensors on the Arduino to feed the Pi, and off you go.
I do that a lot with regular computers too. There's a package. I think I talk about this a little bit later. Yeah, the next slide actually. There's a package that you can use in different languages, including processing, that'll let you read an Arduino from a processing sketch as long as it's plugged into your computer. So that's a good way to get like physical data into processing. So yeah, input, you have a bunch of options for sensors. Adafruit is an awesome place. That's where I go almost 100% of the time.
That's
by
a
kits.
website or something?
Yeah, Adafruit's it's a website run by these cool people in New York. They're really good. They have great documentation, great tutorials. Their products are great. If you're looking for like there's a sensor you really want to do something with, or you want to sense stuff, try to find a sensor that somebody's already built an Arduino library to interact with it, because it's going to make your life easier. Similarly, output, you'll need like physical I/O pins from like an Arduino or Raspberry Pi if you want to drive like an LED display or like a strip of LEDs or a screen. Sometimes a screen, but like motors, things that move. You may have to learn a little of electronics for that, and power, like separate power, like learning enough about like the basics about like amperage and voltage and current. Because like an Arduino or Raspberry Pi alone can't make a motor move. Like it needs to have external power, and the Arduino just saying, "Hey, turn on." So there's some stuff there. So yeah, Adafruit, I would 100% recommend using them all the time. If you need just like basic components, resistors, or some things, DigiKey and Mouser in the US are where to buy those. Mouser has an awesome site. SparkFun is really common for hobbyists. I don't like them. I just have had numerous problems buying stuff from them in the past. Sometimes they're the only option, though. So, yeah, just a little sidebar. Kind of backing to making art that interacts with the real world on the higher level. So this is like you have like a computer or a desktop or a laptop, and more advanced sensors. Like if you want to use the Connect, Simple OpenNI is a library for processing that lets you really easily use data from a Microsoft Connect. So if you want to like track people in a space, great option. Fermata is this library that lets you talk to an Arduino for processing. So you can have like a more complicated processing sketch read it that shows beautiful graphics that reacts to like button presses or something from the real world. Processing also like lets you talk to the web pretty decently. That's kind of if you want to do 2D. Unity has some support for real world stuff. I hear it's got good support for the Kinect and like the Leap Motion, which is kind of like this like mini small area Kinect. It's not as good to probably like stick out like trying to make Unity send stuff to motors or send stuff to like an LED array. It's probably not going to be as easy as like processing plus Fermata. And like Unity's pretty purpose-built for building games as opposed to processing is kind of more general purpose. But if you want to do 3D stuff that takes in input from the real world, especially like a Kinect, Unity may be a good direction to go there. Are there any questions about making things that interact with the real world?
Nope.
Go.
Nope.
I'll try to speed up a little bit because as much as I love talking, I'm sure you guys have better things to do. If you want to talk about things that you can 3D print, so Rhino and Grasshopper are super popular. There's a guy here in Spokane who, screen share again. Whoops. It's a professor here who uses that a lot. Grasshopper lets you kind of do interactive or what's known as parametric design, where you basically create like a system that you can like plug in initial values and then it'll generate a bunch of architecture from that. So you could like actually code out like a pattern that then you could change the input values and it would create a 3D model that would be different based on the input values. It's kind of like a function for creating 3D things. Grasshopper is another like graphical patch-based like draw things and connect them to each other. A bunch of people use it. It's also like a licensee to Rhino is like $1,000. So find somebody who works in an architecture firm or find a college.
I just got it in the lab
So
at Eastern.
The Rhino or the
Yeah,
Grasshopper?
Rhino.
It's patch-based, which is nice. So you don't have to do a lot of like actual coding.
So, but I'm not sure I'm understanding, but I'm very interested in this. like you create a space, and then through coding, that space can interact with the real world, generating something else?
So it's more like you would create like a like mathematical or like model that would be that takes in inputs. Then based on that inputs, it generates like the 3D thing. So like a basic example might be like a Sydney Opera House style thing that you would say, okay, how many peaks to generate? Like generate 5 peaks and go, or generate 1 peak and it'll just go one big curve. That's like a super basic example. Like this guy out at Eastern does architecture that's like more generative, uses like genetic algorithms, uses like really like natural based things to like make stuff where he's gonna enter in some basic parameters for his system, and then his system is gonna automatically create some like weird random geometry that like wouldn't fall down in the real world, but is also like he has no idea what it's gonna look like when he hits run to generate that architecture. Grasshopper can also be used to add like interactive elements, and I know like that develop interfaces, and you can have 3D models that change based on those inputs.
Okay. I'm trying to think of like because I know architects use it, but I'm trying to think. Do you know like any artist that has done like samples? I mean, if you have any example that like an artistic use.
Not off the top of my head, but I'm sure there are tons. I mean, there's a ton of overlap. I mean, actually, I do know somebody. I went to grad school with this guy, Charles Oweda. Go to his site. So he uses Rhino and Grasshopper to generate generative architecture stuff. Oh, come on. Now he does a bunch of robotic art.
Mm-hmm.
So this is a piece of his. So this was parametrically designed. This is and then he projection mapped it. He did a big projection mapping piece for this. So this is, he had an algorithm that said, okay, take in certain inputs and then generate these triangles. And I'm almost positive that he used Grasshopper because like he was an architect for many years, and that was the tool chain that he used. But yeah, so he's working in this space. This may also be a Grasshopper. Yeah, so this is like infused glass modeling.
Wow.
So I should screen share these things. Sorry about that. So this is this project that he did lately. Then they projection mapped over it, but yeah, it was generative. So based on just some numbers, it automatically kind of went and like built this angled landscape, and I would.
So is that a physical 3D thing, or is that just?
Yeah. So then he got this. He probably carved this. He carved this out with a robot, probably, maybe. Yeah. So he also was using Grasshopper and Rhino to make this guy. He did this in grad school. So now this wind thing. Oh yeah, crap. So this is a like piece of fabric that was modeled in Rhino with wind, and so we found like a frame from that, and then turned that into a bunch of precision set nails with his robot arm. This is when Carnegie Mellon's robot arm. He went ahead and like cashed out his 401k and life savings and bought his own. So he's a fun dude. So yeah, so you can do some cool stuff.
Okay.
Does that answer your question?
Yeah. Thank you for showing.
She said something, but we didn't hear it.
Sorry. Does that answer your question? I couldn't hear quite because I turned the volume down.
Yeah.
Sweet.
Yeah, no, I say yes.
Awesome. Yeah, so this is Autodesk products. This is kind of on the they're really interested in the maker community. Have a lot of seems like they have a couple of versions of like software for free now. Autodesk has been used. They started off making AutoCAD, which is a big like architecture program. Then they wound up like buying Maya and 3ds Max, and so they own 3D modeling now.
Wow.
For like animation and stuff. They have really great student and academic pricing as well for like their more advanced stuff. But yeah, like they seem to be super interested in maker community and like trying to like offer like kind of free things to get people like making 3D objects. I don't know a ton about them though. They also own SolidWorks. They own everything. If you want to not pay any money at all and have full-featured software, Blender is kind of the default like 3D modeling software. And because it's open source and free, a lot of people have a lot of stuff that you can take a Blender model and then give that right straight to a 3D printer. Since it started as like, I may have even started as like actually just typing in shit because it's open source and it's been around forever. I'm sure it has pretty powerful scripting capabilities, so you could like program automatic geometry construction. But yeah, open source is short for bad UI decisions. Just a general rule of thumb. So, but since it's free, like, and it's been around for like 20 years, tons of tutorials, tons of videos online for how to learn it. And I mean, it's used in a lot of places like professionally, so it's not like.
So is it? I'm curious about that thing about the user interface.
Mm-hmm.
I mean, I've played around with Blender. It is pretty complex. It's like trying to do AutoCAD without having any training. Mm-hmm. Which you can do. You get through it if you've got some persistence. Is it really that it's a bad user interface, or is it just that it's not intuitive in the way that
That's what makes it
Windows,
a bad user interface.
Well, yeah, okay, but we don't necessarily want everything to be from McDonald's, right?
I think it's, I mean...
You know, McDonald's is a user interface. It comes a certain way. Just because Adobe has dominated, you know, the user interface business in certain places, or Microsoft has, doesn't mean that somebody who's different
I mean, I think there's a really
is bad.
I think there's a really specific problem with open source. I don't want to get too sidetracked on this, but like the people who like program open source stuff are necessarily going to be like just because like the people who are passionate enough to like, oh, I want to go in and like improve this are the sort of people who have already used it forever, and so it's kind of a chicken and egg thing where the people who are using it and designing the user interface and stuff are the people who have already gotten used to everything.
Yeah, I was just gonna say, like, I worked with a guy who was just all about open stuff, and it was like he really had no patience or little understanding for anything. He didn't. So what if it was hard for you to figure out how to use? Like he just sort of had this. I feel like there's like an open source attitude that's kind of like they kind of own that it is not. They're used to it, so therefore it doesn't really matter. Like, it's like it's like an attitude almost.
It's like using the command line. It's like, okay, like you know, everybody's like really into Linux and stuff, and the command line's super powerful and it works for a lot of people. But it also like requires you to memorize all the commands that you want to use. Versus exposing it to new users. So when I say bad UI decisions, it's really more shorthand for this is like not going to be predisposed to not be user-friendly for beginners.
That's all I would say about it. But it's great. It works great. And also, like all open source stuff is great.
Yeah. OpenGL, talking about this again, super powerful. You can do awesome stuff with it. Yeah, real mappy, real mappy. Returning it. So we're going to switch gears and talk about sound a little bit. If you want to do things with sound, like creating generative algorithmic compositions, creating like a bunch of different music, interfacing synthesizers into things and controlling them programmatically. Max, they seem to have dropped the Max MSP branding because it's been all the same thing for like a decade. It's the standard. Like, it's what everybody I've run into who does sound stuff seems to use. It's made this company Cycling 74. It's great. It's not super expensive, like for creative software. It's like $300. Tons and tons of resources. So it's interesting. There's a big relationship between Max and Pure Data. Pure Data is the open source version of Max. Because it's open source and doesn't have a bunch of money, resources going into developing it, it's a lot harder to use. Whereas Max, my understanding, is a lot more user friendly. So yeah, Pure Data totally exists. I tried to learn it and it wasn't very successful, so I make jokes about it. Don't take that super seriously. But yeah, so everybody uses Max MSP to make their cool electronic music stuff. It's kind of driven by. So these are all patch-based languages. Let me pull up,
I found Max pretty fun to use. I haven't used it for years.
That's 3S Max. So that's a better example. That's a good one. So this is what a Max program will kind of look like. You'll have little components here that'll have little boxes at the top for inputs and little bars at the bottom that'll give outputs, and you just connect them to each other, and you'll have this little programming statement that says, if something's true, then do this, otherwise do this. So you can add little buttons and sliders, and all sorts of different stuff, and then you can have patches. So this is called a patch. Then you can have input that you can import another patch and kind of stack things on top of each other. But yeah, it's this really kind of intuitive to me method of okay, we have this little function and it outputs things that go into other things. And, yes, that's what a patch-based language looks like. Yeah, so Max MSP is kind of the big dog here. Max for Live, if you want to use Ableton Live, and Max, it's a little package for it. The whole package for that is $1,000 because Ableton is expensive. Ableton Live's expensive. When you want to do live performance stuff, tons of people are using it. Lots of resources again. If you're here locally in town, Larry Ellingson is a good person to talk to about Max for Live. If you want to mess around with video, Jitter, see, I've never touched it. You have, Jenny? It comes with Max MSP. It seems like what everybody's using for the most part.
I use it. You can have to use very small videos.
Sure.
But I don't know what it can take.
Yeah. So this is kind of me just guessing at stuff for the most part. I've never used any of this.
Yeah.
But yeah, Jitter's been around for a long time. Again, patch-based language. It's Max MSP. VVVV seems really popular. It's a little bit more typing in codey stuff. Actually, I don't know. It might be patch-based. It's a general framework. It seems pretty popular. It's a little bit more open sourcey, nerdy, so it might be a little bit harder to use, possibly. Chords Composer is an Apple product for OS X. You can only use it with OS X, which is kind of a limitation. And it sounds like it's kind of being ignored by Apple, so it may disappear. But yeah, a lot of people seem to make stuff for it. Apple stuff probably has a reasonable UI. One thing to brush up on if you want to do stuff with video codec or with video is learning about video codecs, which are basically how video is stored and compressed. The a lot of different formats for different reasons, and depending on what you want to do, having your video in the right format can make the difference between your thing running smoothly and your videos like running at like 2 frames a second. I don't know a ton about them. It's something I wish I knew more about. If you wanted to get into any projection mapping, that's something you should like brush up on. Just figuring out what format your videos can like easily run versus not easily run. So, yeah, I'm gonna get into the more specific things. You want to glitch stuff? We talked a lot about data and kind of binary stuff last time in hexadecimal. There's going to be some program. You can do some stuff programmatically, which will be fun. Kind of the first step for most people, I think, is just starting to mess around with just basic tools with glitching things and messing with data. Audacity seems to be pretty popular. It's like a sound editing program that's free and open source, but it has an option where you can go like file, open just arbitrary data. You can like open up a text file or an image file, and then you can do. It'll pretend that it's a sound file, so you can then change the volume or change the pitch or do all sorts of weird stuff with that, and then save it back out as an image or text or whatever, however you want, and you'll get all sorts of crazy effects.
Audacity is super cool for sound and
Nice.
and it's free.
Yep, totally free. Yeah, and like Audacity, it's open source. It does a pretty good job with having a good UI. There are something just to be aware of. So we talked last time about how the reason that one of the reasons to use hexadecimal is that evenly, every 2 hexadecimal digits represents like a even byte. Like, so you can edit individual bytes without changing the rest of everything. You can download various hex editors, which lets you open up a file and just like as a binary, like string of 1s and 0s, and like look for patterns or mess around with things like on the byte level, kind of like messing around with like the raw data of image of whatever you want to do. The next step for here would be learning like more about data and how it's actually encoded. I might consider learning some basic C++ to learn kind of more about memory use and more about types, because the C++ operates closer to like the actual processor than other languages that are in mainstream use today. So the closer you get to like the actual processor, like the more you have to like be aware of what's actually going on with the 1s and 0s. Similarly, learning more about actual data types. Endianness is this concept of, so we want to store 8 bits to make a byte, but like is the order like smallest bit, or you basically, if you're storing like the number 100, use a base 10 example, would you store like 100 or 001? That's different for different processors. Little endian versus big endian. You can look it up on Wikipedia. It's kind of fun. What about bit manipulation? So the bitwise operators that we talked about, those are super fun to mess around with. Then I'd learn a little bit about data streams and file I/O. That's like how programming languages actually like interact with like files on your computer. So you'll actually be able to like load in a file, and like, when you load in a file, it generally comes to you as this big like long stream of 1s and 0s. So being able to mess with that. Then packets and datagrams. This is how. Let's get this grinding in a little bit. Yeah. So packets and datagrams are basically how data gets sent over networks. Like your image or whatever will get like bundled up into a bunch of little groups and sent out over a network. Languages to use if you want to do glitching programmatically. I'd probably do something like that's strongly typed, like C++ or processing, basically, so that way it gives you more control over like more assurance that like your 1s and 0s stay in the order that you started with, as opposed to like Python does weird stuff like numbers are like infinite characters long or infinite digits long, the way that they're stored internally in Python, and it's weird. It's going to break Can make it a lot harder to do intentional things with glitching. You want to do stuff on the web. Rhizome gives out like $500 micro grants like once or twice a year for a bunch of people. So that's nice. You absolutely need to learn some HTML and CSS. It's pretty good stuff. Just like, okay, HTML is just going to be, what's on your web page. CSS is like, how's it going to look? Once you kind of have some basic HTML and CSS kind of understood, processing.js, which is really now switched over to p5.js. It's like an implementation of processing in the browser. So if you learn processing, processing.js, like lets you just like literally copy paste processing code into like a container on your website, like a canvas object that's running like processing.js, and it just runs it straight up. P5.js is like a port of processing into JavaScript, so you'll actually be writing JavaScript code, which is pretty similar to just processing. That's what's being, like, processing.js stopped getting developed like 2013 or so. And P5.js is currently being like one of our residents actually spent some more working on it. P5.js is getting all the fun things like access to camera, access to sound stuff that browsers are more and more getting access to, like sensors on your phone, like sensors in your computer, things like the camera, things like accelerometer, GPS. So P5.js will probably let you mess around with them as they become available in the browsers. But yeah, the big name if you want to do anything on the web directly is interactive is JavaScript, and God, it's terrible. And also my favorite programming. So O'Reilly is this company that makes programming books that have black and white minimalist creatures on them. They're kind of famous for doing everything. This is the classic image. So they got this book on JavaScript. JavaScript, the good parts. Yeah. So JavaScript has a really weird history. It was started in Netscape in 1994 to make things turn on and off on the internet. Make your website, your GeoCities page look cool. It was just slapped together with no real rhyme or reason for a very long time, which is why this is about phone book. Yeah, and so it's gross. It does weird shit. The one thing that you can't. Yeah. One thing that's actually really weird, don't delve too deep into this about JavaScript, is that all the programming we've been doing is synchronous programming. So it says step 1 runs, then line 2 runs, then line 3 runs, then line 4 runs. JavaScript tends to be coded in this asynchronous way, which is because JavaScript is okay, we want an image, I have to go talk to a server and see if that image even exists, and then wait to get that image. And so you probably don't want to wait 200 milliseconds for that to happen, or the minute for that to happen, or however long it might take. So you're going to go ahead and ask me to get you an image from this server, and then I'll let you get back to what you were doing, and then I will tell you when I got the image finally for you. So instead of everything being neatly in order, you've got all these things going on simultaneously in JavaScript, or web programming in general, really. So that's a big transition to make for doing more advanced stuff with JavaScript. Just prepared for that. Plus side is that there are tons and tons of resources for JavaScript because it's been around forever and it's what everybody has to use, because there are some alternatives out there like Go and Dart, but they're not really supported like JavaScript is. So if you're going to use JavaScript, everybody does this. They use the library to make it better. jQuery is super popular. It makes it really easy for your program to like find things on your web page. AngularJS, React.js, Ember.js, all the web apps use these like toolkits. Angular comes out of Google, React is from Facebook, Ember's from somebody pretty big. So there's all these like toolkits for making web applications and like making UI design elements that like are nice and pretty and like work with phones and like when your screen size changes. It's make it way easier to make JavaScript that doesn't like try to murder you in your sleep. If you want to do any 3D graphics, this is like they'll probably have to like do some like OpenGL type stuff, but 3.js and Babylon.js are ways that you can do 3D stuff on the web and or just get access from a browser to the GPU, which lets you do some like powerful. If you need to like crunch a lot of specific numbers, GPUs can like really help with that. That's kind of an advanced topic though. You really don't want to learn JavaScript, which I do not blame you. There are a lot of options, so in order to like try to make a go of things, like Google invented both the Dart and Go programming languages, which are like easy to use in JavaScript, but they're designed so that they can actually like compile straight into JavaScript. So you can like write your thing and then hit a button and then it'll spit out JavaScript for your web page. Yeah, exactly. So they're translatable languages that you can use if you want to be like ahead of the curve. Show you the nerd cred. Yep. The other option would be to use something that's just gonna spit out HTML5. Like Adobe, like finally is like, okay, everybody's saying no Flash anymore, so they're taking all the Flash tools and they turn it into Animate. You can actually spit out HTML5, aka JavaScript and CSS and stuff. Unity is on the cusp, I understand, of being able to spit out native HTML5, or at least be able to run without a plugin. But like the Unity plugin is also has a really large user base of installed people because people love playing games on the web. And like 3D stuff, especially, Unity also be a really great free option to do stuff without go through the abomination that is JavaScript. Finally, if you want to do apps on the phone, which has been super popular for art stuff, it seems to be a little less popular now that everybody's kind of like gotten over it. If you want to do something system specific, if you want to program for Android, you got to use Java. If you want to do for iPhone, you used to have to do Objective-C. Apple's been developing this Swift programming language for a couple of years now that everybody's migrating to. So you should probably absolutely use that. But it's going to be a more useful tool to have in your toolbox for development on iPhone. On the plus side of using these things, so you'll have the most up-to-date access to like all the options on the phone. So like Swift, if the iPhone comes out with fingerprint scanner or whatever, like Swift is going to be able to be like if you're programming in Swift, you'll be able to go, hey, let me access that fingerprint reader as soon as it's available. The bad side is that you have to pick one up. Like you're not going to be able to write your code for the iPhone is not going to work on Android and vice versa. So to get around that is cross-platform tools. Unity, again, this shows up a lot. The biggest reason that Unity got super popular and made a bunch of money was that for the first several years of their existence, they had like plugins, so you could write your game in Unity and you could export it to iPhone or export it to Android, and they sold like that export functionality for like $500 each. Wow. That functionality is free now. Because there's been a lot of like kind of competition and like, hey, let's make it easy to make games for those things. But yeah, so Unity is a great option. You can do 2D stuff in Unity as well. Otherwise, PhoneGap or Cordova, which is now called Cordova, which is an open source thing with the Apache Foundation, or other frameworks that let you code in one language and then it basically will like translate and kind of you feed your code into like Cordova, is my understanding. You feed your code into it and then it spits out code for both Android and iPhone. Finally, more and more access to phone features is being given to the browser, so it's kind of where things are headed anyways. It seems on a macro level, web apps. So design a web page that people can go to on their phone using JavaScript, unfortunately. But yeah, like you're starting to get a lot of, like, especially with Chrome, a lot of like cool things that you can actually directly access from JavaScript on anybody's browser. So that's an option, just to write a web app that sits on a server somewhere that people can navigate to, rather than having to download an app, get permissions or whatever. There's some good choices, good reasons to make that choice. Yeah, is there stuff I've covered that you guys, or haven't covered, that you guys are interested in looking into?
Like, employers are looking for people that can code. I mean, can you explain a little bit of that? Do you know, like, what language they use?
JavaScript.
Okay.
If you learn JavaScript, you will never go hungry. It's never going to go away, I doubt. I mean, not within the next 5 years, 5 to 10, just because, like, it's the total chicken and egg program. Like, Google's really been like, hey, JavaScript really sucks. So we're Google, and we're going to invent, like, Dart and Go and make these things that you can code in that are way easier, way faster, way better to use. But since everybody's browser runs JavaScript, and people use different, people use Chrome, people use, Edge, people use Safari. Like, until all of those browsers support Dart or Go or Rust or whatever it is, they will never support JavaScript, and so everybody has to keep supporting JavaScript, and so everybody writes everything with JavaScript. Yeah, and it's gotten a lot easier to use. There are all these frameworks that have made it safer and friendlier. There's tons of courses out there that you like, tons of coding or web coding boot camps that you can take that will, like, guarantee you job placement afterwards. So that is the easy answer to that question is JavaScript. That being said, JavaScript is an abomination to say. So yeah, there are a lot of other great options, just that they're going to be, people still program in, like, C# for, like, applications that run on Windows. People code, like, certain, like commercial applications, especially for businesses. People write in, like, there are people looking for game developers who write stuff in Unity a lot, because everybody's using Unity to develop video games. Database languages for database administrators. So, like, if you want to work with, like, big data, learning database stuff, so SQL, so SQL. There are a couple of weird things. So, like, SQL is like structured data. There's this new thing, like NoSQL, which is like databases that consist of unstructured data. It has, especially when you're working like really big data sets, like Google and stuff and Facebook. There are, like, performance reasons why that it's better. I don't really know much about database programming, but yeah, I mean, there's definitely a lot of stuff in there because people have tons and tons of data that they need to sort through in database programming languages, which really are, like, you'll use a programming language and then you'll just use, like, functions that allow you to, like, write a program in Python or C++ or Java or whatever, but you need specifically these functions that, like, are database functions. So kind of database programming is kind of a subset of using a different language. But, there's a lot of stuff like, like search operations and query operations and replace operations and sort of things. Data. Yeah, data analytics is definitely something that's super big and going to be growing for the foreseeable future. So that's a great job to learn. And yeah, I mean, if you learn, it tends to be like lots of data out there, lots of public data.
Other things, but they used to talk about web spider, web crawlers. Yeah, they would search data that's on the web and find certain keywords. Is that related to database stuff like you just said, or where does that fit in?
Yeah, so like, so web scraping.
Web scraping.
Yeah, so there are various,
I like
various
it.
programs you can use, like with Linux, and so also probably with Mac. There's a command line tool called wget, which you can say, hey, go get me data from. That's actually kind of a specific thing, like internet programming, like web programming, learning about like how. So this is actually really annoying because if you want to start learning JavaScript or whatever, like web programming, like they're going to give like all the instructions are like, hey, here's like how to do hello world, here's how to make a website look pretty. But if you actually want to like send stuff back, they're like, okay, we've got you this, or we've got you this like basic website running. And they're like, hey, so here is all the documentation. You know JavaScript now. And that's totally not true, because then the documentation's all like, well, in order to do this, you just send a post request to your server on port 8085. So there's like a big gap in the middle of like, so what the hell is a post request? What the hell is a port? But yeah, so there are these tools that, so yeah, basically whenever you type in, Facebook.com, your browser hit enter, your browser sends what's known as a GET request to the server at Facebook. It's got this like kind of program running that's just listening for data for internet packets to come in that are these GET requests. And the server like gets that, calculates it, and uses that GET request to build a web page dynamically that it spits back to you. It sends back over to your browser that your browser then reads and interprets. So wget is like a command line tool that just in your website, and it sends a GET request and spits back out like the data that the server sends, so the web page. Yeah, so you could you could use that as a tool to automate searching. I had a program that you could
like one of those nail gun arms.
Yeah. I had a program that needed to listen to an email account, so you could send a text message to this email account, and then it would use this wget command to search Wikipedia and send back a series of text messages to you with the first paragraph of the Wikipedia article. So the web scraping. So field data for me.
Scraper. Write it down.
I have to write that word down. I think that goes with glitching stuff.
Meeting.
Are there any specific areas that you guys are interested in? Lauren?
No, this was very useful to connect all these possibilities.
Yeah. So, so this course, I was trying to mess around with Python. Subsequent iterations, I'm just going to go ahead and switch to processing because it's for a couple of different reasons. But, yeah, kind of my hope for this course is that it, kind of gets the abstract concepts behind it. These concepts are universally applicable to all these different languages and frameworks. It's just kind of the different programming languages. They're different features, but they're just so you tend to be saying the same things just with different words. So.
Yep.
Do you have any more questions?
No, I guess. Are we gonna have all these classes are on YouTube if you want to watch them again?
Yeah.
Okay.
Feel free to send me emails, send me, hangouts or whatever. Happy to, as you guys move forward, I'm always happy to give technical advice and,
Yeah. I will get in touch with some questions.
Yeah, I think that programming for me has been really fun, interesting problem solving, and you can make some cool stuff with it. And I hope that you guys can make some cool stuff too.
I we make some stuff.
Yeah.
So many questions.
Yeah. All right. Well, thanks for
All right. Thank you so much. This
Thanks.
was great.